My office hour will not be recorded. My lecture will be recorded. Okay, so if you don't want your name or your picture shows up, feel free to change your nickname on Zoom, disable your video, or change your picture profile. Okay, now the recording will be posted on YouTube and make available to public. Now let me go over the announcement first. Uh-oh. Give me a second. Continue. On the announcement, we have two announcements. First one on attendance. I don't need you to attend the class like synchronously with me, but for formality, I need you to reply here on the discussion board. Where's the discussion board, Thomas? Let me do the discussion first. Discussion on intro, and then we will do 6.1 today. Now then, to say that you are present for this class, just reply here. Reply here. Okay, now I will leave this discussion for today for 1 week. So in case some students cannot attend the class today, they can say they are present tomorrow. I don't mind. I just need a formality that to tell me and the college that you are active in this class. Okay? Yeah, so let's see. Suppose you go to students view. If what you see will be something look like this. Go to discussion. Click this one and say here. Okay, well, we have some students already do that. Thank you. That's for your attendance. I need that for formality though. I need that for formality. So like under what situation a teacher can drop a student? When that student missed more than 1 week of the class. Okay, now I don't really want to enforce it, but at the same time, in case later on the dean, let's say, ask me, Thomas, Thomas, why don't you drop this student? Then I need something at my hand to justify me keeping you in my class. And that's why I need you to do your attendance there. Okay, I leave it there for 1 week. So let's say on Wednesday, then you put here, it's fine. But next week at the beginning of our class, no, Monday we don't have class, right? Monday we don't have class, but before 7:20 next week, I will close that that discussion board for today from new comments. Okay. Anyway, that's for attendance, and I have lecture video from spring 2020 last semester for the lectures after we move online. As I know, we were working on 7.5 at that time. So from 6.1 to 7.4, I need to do the lecture in class. But after that, I will ask you to watch the lecture video outside of class, okay, during your lecture time. And then during class time, we will do exercises, okay? So the first 1 month, maybe I would say for the first 5 weeks, we'll have lectures, okay? But then after that, you already have lecture video you can watch from my last semester. What else? Testing procedure. There are 2 parts about testing procedure. First one about proctoring. I need you to have your camera on, showing me your test, your face, your hands, your test, your desk. Okay, to be more detailed, please watch this lecture, this video clip here, so that you know what to do, what you need to during your test later on. How about your test itself? How will we do that? Now, I will post your test in PDF, the PDF of the test on Canvas at 7:15, and you need to fully upload it back to Canvas at 10 o'clock. So you have 2 hours, 45 minutes to do your test. Now, how will you do that? Basically, you will print it out, work on it, scan it to PDF, and upload it back to Canvas. So there are 4 steps. Some little issue. Thomas, what happens if I don't have scanner? Then very likely you have, as I know, everybody here has a smartphone. Now, if you have smartphone and you have Android, then you can download this app, Cam Scanner, learn how to use it. Okay, if you use iPhone, I was told, I don't use iPhone, so I heard this from students using iPhone, that there are some apps in Android can take pictures and convert it to PDF. Okay, basically you figure out how to scan it. Either you use the actual scanner, you use the app to scan it, convert that to PDF, and then you upload it back to Canvas. Okay, now if you have feature to write directly to file, let's say you have tablet, you have notebook, you have iPad, I have Expand, okay, such that I don't need to print it out. I can just write it directly to the file. If you are in my situation and you feel comfortable to do so, then go ahead, just do it that way. You don't need to print it out. You can just write it directly to the file, save it in PDF, and then upload it to Canvas. Now, I strongly suggest you to have printer though. Okay? But what happens if you don't have printer? In case you don't have printer and you don't have any way to write directly to your file, then your last option is to write on paper. So you grab a blank paper, okay? You don't need to write the problems anymore. You don't need to copy the problems down, and just go ahead, write your work. I try to write questions in which, even if you need to copy the problem, it's not a lot to copy. That's what I try. Okay. Now, however, however, I found most students who originally use this method, that they use the blank paper, end up telling me that it actually slows them a lot. And actually, most of them end up getting printer. In my opinion, getting you're a student, so you need a computer, right? And after computer, get a printer. Now, of course, I don't want to enforce it as if that's something you have to have, especially during this time. I know we are more restricted financially, right? So I don't want to make it as required, but highly recommended. Okay, highly recommended. If you know me enough, you know that I'm someone who tries to save your money as much as possible, as much as possible. If you don't need it, don't buy it, okay? But this is the one that I try to think if there's any way for me not to even recommend that to you, and it turns out that still no way. Well, so try to get your printer, okay? Try to get your printer. You still have 1 month basically to get this printer. So there's no rush that you get it, and get the cheap one. You don't need to have a color. Yeah. And as for the scanner, learn to use this Cam Scanner. Oh, by the way, I have some students actually they have actual scanner at home, but they say Cam Scanner is actually faster. Cam Scanner is actually faster. If that's what you feel, up to you. Up to you. What I want is you have reasonable access to the test. You can do well in this class and post it back online. Now, on the last paragraph here, I tell you that we have assignment 0, homework 0, quiz 0, okay, as an extra credit, so that you have a little experience about how to turn in your test. Now, how to find that assignment, you go to assignment here, quiz 0. You print it out, write on it, scan it, and then submit it. What happens if I don't have printer, Thomas? Then you write it on a piece of paper. Okay, but I need you to write it though. And then scan it. What happens if I don't have scanner? Then use cam scanner or other way. Basically, take the picture, convert that to PDF, and then submit it. Now, how do I submit the assignment, Thomas? Let's get the student view. So let's say you print out. Once you're done, you want to submit it, you submit the assignment. You click this one, but clicking this one does not submit it though. It just brings you to a page where then you see the direction how to submit it. Okay, so you click that one, choose the file, which PDF file, and then you submit it. Okay, now that's for the first announcement. Second announcement, it's about textbook and calculator. We will use the 7th edition of James Stewart. This is what it looks like. And because this is Calculus 2, very likely you already have this textbook from your Calculus 1. Now, let me know if you don't have this textbook. Let me know if you don't have this textbook. If you don't have this textbook, you can study from an older edition. I post some pages from the 5th edition James Stewart here. Yeah, but we will use the 7th edition though. The pages and the numbering, the problems may be different, but the content are pretty much the same. Now, if you use the 5th edition, I think you will see that in chapter 7 instead of our chapter 6. We will start from chapter 6 in our textbook. The 7th edition will start from chapter 6. But in the older edition, the 5th edition, our chapter 6 correspond to the 5th edition, chapter 7. Okay. Now, how about calculator? You will use scientific calculator, not graphing calculator. But Thomas, I already have TI-84. Can I still use it? Okay, fine. But don't use the graphing capabilities. You will get error message. Or the graph that you get may be really funky. That's not really what's supposed to look like. Okay. Well, that's because your graphing calculator, TI-83 or TI-84, the way they graph it, they don't graph it to scale. They graph it to scale such that at times you cannot really see important feature of the graph. Okay, so get a scientific calculator. I recommend TI-30 or TI-36, as you can see from the links here. Now, you don't need to buy from here though. You can just buy from Staples or from Office Depot, or you can borrow it, buy from eBay. Doesn't have to be from Amazon. Okay. Any questions so far? No question. Okay. This class is from 7:20 to 9:50. We will do the lecture from campus through Zoom. Now, some things to say about the office hour. I have a class right before this class, so I cannot really have an office hour before this class. So what happened is this. If you have any question you want to ask me, you need to send me an email first on either one of these days. Okay, Monday, Tuesday, Wednesday, Thursday from 3 to 4, or Tuesday, Thursday from 10 to 11, that you want to ask me question. Actually, you don't need to. You can just ask me question by email too. You can ask me question by email. Okay, and if I think I need to talk to you in person through Zoom, then I will ask you, hey, you know what, can you go to Zoom? What time? And then we meet during that time. Okay, yeah. On the other hand, I would like to have a weekend office hour. Maybe I say it this way. My Tuesday, Thursday, 3 to 4 o'clock, I would like to change it to Saturday. But I don't know what time on Saturday will be good for you. Now, if you want to utilize my Saturday office hour. Now, if you don't, then you don't need to tell me. You won't be there anyway, right? But if you think, oh, Thomas, I'm a Saturday person, and I would like to have some office hour during Saturday, then you tell me what time will that be. I give you 2 hours on Saturday. If possible, not too close to lunchtime. Okay? If possible, not too close to lunchtime, not too close to dinner time. I prefer the morning though, like let's say 8 to 10. That's what I have in mind. But at the same time, I would like to get your input first. Okay? Yeah, but well, send me an email on what you think will be helpful for your study. We have website for this class. I will show you the website later on. Okay. Oh, supplemental textbook. I recommend you to get these 2 books here. Highly recommended. You don't need to get the newest edition, no need. In fact, Calculus by Howard Anton, I think the current one is like the 11th edition already. No, you don't need to. You don't need to. You don't need to have the 11th edition. You can get, I have the 5th edition, but people say the 4th edition will be the best. And Thomas Calculus by Thomas Finney, but this Thomas is not me, not me, the one writing it. No, Thomas Calculus, any edition is okay. I have the 10th edition. I think the current edition already the 15th, even 20th edition. No need. If you can find the 5th edition that costs $5 including shipping, go for it. Okay. Yeah. Important topics from Calculus has not changed in the last 100 years, maybe. Prerequisite, you need to have passed Math 261, Calculus 1. And course description. We will cover integrations, logarithmic, differential, hyperbolic functions, inverse, indeterminate, a lot of integrals. Basically, technique of integration, chapter 6 and chapter 7. And then the application of integration. Okay, and then infinite sequence and series and power series. If I go back to my notes, basically this is what we will cover. Chapter 6 and 7, that's integration. Technique of integration. Okay, and then chapter 8 will be application. I think I need to say 8 and 9. Chapter 8 and 9. Will be the application. I will skip chapter 10. Chapter 11, sequence, series, and power functions. Power series as a representation tool. Okay, that's what we will do in this class. Grading, 10% of your homework. And for the test, we have test 1, 2, 3, 4, each 15%. And the dates are given there. Now, these dates are pretty much set in stones because from my experience in the past, I can finish the material for test 1, for example. The material for test 1, I can finish the material 1 week prior to that. On September the 30th, I'm done with the material for your test 1. Okay, for your test 2, I finish the material for your test 2 on October 21st. So even if I'm a little bit late, okay, I still have 1 day to do the adjustment, okay, such that our test day will not be moved. Our final will be on December 16th. The grading cutoff, my A is 90%, I don't curve it. My B is supposed to be 80%, I curve it, make it 79. My C is supposed to be 70%, I curve it to 68. Okay, so I curve the grading cutoff, and on each one of my tests and final, I also give extra credit. So Your overall, if you don't miss any points throughout this semester in this class, then your total average maybe 105 or even 106%. Now, of course, you don't need 105% to get an A. You just need 90%. Okay, you just need 90%. But as you know, this class is a tough class, and if you know if you know me enough, if you hear my name from tutors, then you know that I'm not an easy teacher too. I hold my standard, especially when it comes to this calculus level. Okay, please study for this class. Important dates: last day to add to drop without W is September 13th, approximately 2 weeks from now. And last day to drop with W is November 22nd. I hope you don't need those dates. Any questions so far? No question? Okay, I go on. Notes. The first one, having a textbook is a must. No one without textbook ever passed my class. I can assume you already have this, I can assume that you already have this textbook, okay? But if you don't have textbook, then get it, okay? I don't care if you get, I don't mind, I don't care. It doesn't matter how you get it, just get it, okay? You can buy it, you can rent it, borrow it from your friends, do something, okay? But here's the thing, if you don't have a textbook, you basically don't have any resource to study from. You basically waste your one semester simply because of a textbook. Now, we use the 7th edition. I know it's still a bit expensive, but the current edition is the 8th edition. We are already using a previous edition so that you have cheaper access. And not to say that if you want to get it cheap, you go to eBay, you go to Amazon, let's say, you rent it, and while you wait for that book coming to you, you can use this, the previous edition, 5th edition, for maybe for a couple of weeks, okay? Now, I give you 2 weeks to get your textbook. So in the first 2 weeks, until 2 weeks from, so how to say it? So let's say until September the 14th, okay? September 14th, you should have the textbook already. At least I assume that you have the textbook already. I try to make it in a way such that my lecture does not interfere with the fact that you have or don't have the textbook with you. I try my best, but still you need to have a textbook to study at home. Okay. Second, I do not require you to attend my lectures synchronously. However, I need you to reply here on each day on discussion board for that day. Any 2 consecutive days of missing such reply gives me reason to exclude you from class. It is not my interest to drop you. But if you are not active, I would like to know that you are not active such that I can talk to you. And at times I need to drop you first to get your interest. Strange, huh? Okay, so if for me to get your attention is by dropping you, then so be it. I drop you first. Okay, then you come to me, Thomas, why do you drop me? Well, because you are not active. What should I do to pass the get reinstated and pass my next test? Okay, now, but I require you to be synchronously online during any test and final. In other words, we're supposed to meet 31 times in this class. You're supposed to attend my class 31 times. But I make it in a way such that you don't have to be synchronously online together with me, except for these 5 days here. These are the dates. Okay. So what happened, Thomas, if I work on in the evening? Then ask permission ask a day off from your employer. But Thomas, my employer will not let me take a day off. Then why do you take this class to start with? This class is supposed to run from 7:20 to 9:50. You're supposed to be here. The fact that I let you go for the other 25 times, consider that already as what you call it, an accommodation for you, right? But for these 5 days, I need you to be here. Okay? For that 5 days, I need you to be here. No makeup test or final. Exception only given in case of emergency and or legitimate documented absence. Now let me talk about this makeup test. Makeup test is not retake. Makeup test is not retake. If you took the test and you don't do well, I still use the grade. Okay, I still use whatever you earn from that test. But I also would like you to know the law. The law says that under what situation, under what circumstance, your instructor is required by law to accommodate. Cases when your instructor, including me, but not only me, everybody in this state, your instructor is required to accommodate your absence. First one, jury duty. So in my class, in my case, if my test happen to coincide with your jury duty, let me know. Okay, of course, I need some documentation. You need to provide me the jury duty paperwork. Okay, but I will be happy to accommodate you. I am required to accommodate you, but I will be, on the top of that, I'll be happy to accommodate you. The second one, military obligation. Let's say you suddenly get an order from your commanding officer and you need to take a day off. It happens to be on the test day. Then let me know. Of course, provide me a copy of the paperwork from your commanding officer. Then I will accommodate you. The test, a makeup test, should be done before the next meeting. So let's say today we have a test. Then you need to do the makeup test. You need to do that makeup test by Wednesday. Okay, by Wednesday. But of course, if Wednesday you still have the same situation, then you still have excuse. Okay, these are the cases that in which your instructor is required to accommodate your absence. Actually, there's one more. Religious obligation. Now, if you know one of the test day happens to be the day that you have your religious holiday, let me know in advance. The rule is, the law is that you need to tell me in the first 2 weeks of the semester. So even though your religious holiday is on week number 13, you need to tell me by the end of week number 2. But with me, I don't mind. If your religious holiday, which coincides with your test, happens to be on week 13, and you tell me on week 12, I don't mind. I don't mind. Just let me know. Okay? I don't want to be too strict with the law, but I need you to know what the law says. The law says only in these 3 cases, I am required to accommodate you. Now, what you don't see here is when you get sick. I am not required to accommodate you if you get sick. In fact, your health is your responsibility. Okay? Now, of course, even though I'm not required to accommodate you when you get sick, I can, right? Every reasonable instructor will allow some kind of accommodation in that situation. Now, but I do not give more than 1 makeup test. Going back to my syllabus, I do not give more than 1 makeup test. only one makeup test or final will be allowed. Okay, so let's say your test one, you happen to be sick, so I'll give you makeup test for your test one. But once you use that quota of making up test one, you don't have any chance to do makeup test anymore for the rest of the semester. You see what I mean? But Thomas, what happened if I happen to get sick again for other day? Well, something wrong with you. We only meet 5 times for the test, and you actually hit 2 of them. But Thomas, it's possible to happen, right? Yes, it's possible to happen. Don't forget, I did my PhD in probability and statistics. Even though it's possible to happen, it is even more possible you purposely make yourself sick during that time. Okay, speaking about probability, everything is possible. But how likely it is? I have a student in the past who actually missed 3 of my tests. Asked for makeup test 3 times in that one semester. And all 3 of them because her grandma's passed away. It's just like, because he took my class, he lost 3 grandmas. Because all 3 grandmas happens to pass away during, on the days I gave a test. That's so strange. Think about it. What's the probability? It's even more likely somebody make up stories, right? Okay, so no, only one makeup test. But Thomas, bad things happen to good people, bad people. I know, but if you happen to have an accident, let's say, such that you go to hospital twice, and both of them happen to be my test days, something really wrong with your driving. You know, okay, like you have been driving for 10 years, never have accident, and all of a sudden you take Thomas class. Of 5 days that you need to take tests, 2 of them is your accident day. Strange, don't you think so? No. Once you learn probability, then you will see that's actually very, very unlikely. Next, knowledge homework will be accepted. I will give you at least 24 hours to turn in your homework. In fact, I try to give you a homework that has a weekend in between. You know, so nobody can tell me later on, Thomas, I don't have time to do the homework. Nah. Okay, if you don't have time to study during the weekend, something really wrong with you. Something really wrong with you. Okay, I give you at least 24 hours. In fact, I try to give you a weekend for that. Now, during test and final, you are required to be online. I said that twice already. I said it again. You are required to be synchronously online with me, with your test, your stationery, your desk visible and audible at all times. No, I don't curve your grade. I already curved the grading cutoff. I give you extra credit, but we need to say stop at one point. Studying hard sometimes results in good grade, but never expecting a good grade if you don't. Testing policy, closed book, closed note. Scientific calculator required, but no graphing calculator allowed. I have a student, actually 2 students try to use graphing calculator secretly last semester. You know what happened to them? They dropped the class. They don't do well anyway. So they end up failing the class, not because they use graphing calculator, no, but because they depend on graphing calculator such that they don't see important characteristic of the graph they get, because the calculator, the screen of your calculator is too small to incorporate all important ingredients. Warning for repeating students, don't skip class, don't get behind, okay? Point number 10, you may be recorded during any test or final. Okay, I don't want to record you during the lecture, but during the test, I need to record you for 2 reasons. First one, such that I can tell my math department that I proctored the test properly and I have evidence. Second, if I have students cheating, I have evidence at my hand also that that person is cheating. Okay, but the California law does not require me to have your permission to record you, as long as I tell you in advance that you are recorded. And this is what I'm doing right now. During the test or final, you may be recorded. Okay. For your homework, however, if I give you homework, okay, not a test, not a final, just homework or a quiz, I want you to work together. For homework and quiz, I want you to work together. Have group study, okay? Of course, you need to write your own solutions though, but I don't mind you to work together. I encourage that instead. Only for test and final, I don't allow that. Now, I recommend you to take at least 2 hours, not 1 hour. 2 hours to study every day during this fall, not spring, okay, such that you have that study habit. The fact that you are in this class, very likely because you are you already have that study habit. But once in a while, I still find students end up in my calculus too without knowing how to be a student first. That's very strange, I know, but it happens. It happens. Academic dishonesty, just don't cheat, please. Okay, please don't cheat. How about students who needs accommodation? Please contact this number and take care of the paperwork as soon as possible. They're quite slow there though. They are quite slow there. So if you need accommodation, contact them and then they will do the paperwork and they will send me an email about the accommodation you need. Okay? Student learning outcome, don't worry about it until the final. And these are the dates I will do the lecture and the test. But the one that you need to be synchronously online together with me, only these 5 days. Okay, so I expect you to be online, have video, the webcam of your face, your desk, your test, at all times throughout the test. Okay, that's for my syllabus. Any questions so far? Any questions so far? No question. Okay, let's go to my website. My website is one of the most crucial part of my class. No one passed my class without knowing my website. So get used to my website, okay? Now, my website is harjuno.com, basically my last name.com. I share this website with 2 other instructors at WLAC College, but this website belongs to me. They just borrow some space to put their material. Oh, by the way, you see this picture? This is my university back in Indonesia. I am, as far as I know, I'm the only math instructor at WLAC College whose undergrad is not in America. I did my undergrad in Indonesia. I'm the only math instructor, as I know. Well, anyway, I'm Indonesian. Okay. So you can speak Indonesian to me, even though, no. As a teacher, I still use English, okay? Now, why my website is important, because if you click my name or you pick my nose, you will get to my page. And on this menu here, go to teaching. On the drop down, click previous teaching. Then you will see the list of classes I have taught at WLAC College since fall 2007. And actually, if you scroll down further, you will see the classes I taught at East LA College and Santa Monica College. Now, if you say Santa Monica is a better school, you go there, you see me anyway. Okay, now, well, Santa Monica has better infrastructures, but teacher-wise, student-wise, pretty much the same. Pretty much the same. In fact, one student said earlier, one student said that he prefer WLAC College because it's not as crowded. Yeah, the parking at Santa Monica is crazy. Even for instructor, imagine that. You know, good thing right now we don't need to go drive, let alone park. Well, anyway, Why is this website important? Because you will get access to my old tests from here. So for example, in spring 20, I don't know if I posted there. Yeah, in spring 20, so last semester, if you scroll down, look for Math 262. So you see Math 262 here? Are you seeing what I see? Okay, so you see Math 262 test 1. This is the test they have last semester. Not a sample test. This was the actual test they took. And my test will be quite similar. Not super similar, not exactly the same, of course, don't expect that. Okay, same questions maybe, but different functions. Okay, and you can see, oops, where's that? And you can see this is my test 1. Oh, I don't have the solution, huh? Test 2, I think I have the solution, but I don't remember where I put it. Okay, test 2, this is the blank test. Don't be afraid, don't get intimidated by these 12 pages. That's because I give a lot of space. You see, question number 1, 1 page. Question number 2, another 1 page. Question number 3, another 1 page, right? Okay, so that you have a lot of space to show your work. The thing is, I also want to show you the solution for this test too. So I show you the blank test so that you know what to expect from me. And I show you the solution so that you know what I expect from you. Do you make up your own test questions or use the book? Mix. In fact, I also get questions from other universities. Most of the time from other universities. I'll show you later on. Remind me if I forgot. But yes, most of the time I pick questions from other universities. Why? Because when I write my own question, most of the time it turns out to be harder or on the hard side. On the other hand, questions from textbook tend to be on the easy side. Or at least very likely those problems already done somewhere, either during my office hour, during my class, or what's that? There's a website where you can find the solution. Okay, so I tend to take problems from other universities, or I write my own test. Do I give partial points? Yes, I give partial points. In fact, I grade your work more than your final answer. So you can see here, this is the solutions. This is the perfect solutions, right? Okay, now imagine if you don't show me any work here and you just suddenly come up with the solutions. I have no reason to give you any point. See, show all necessary work neatly, clearly, systematically, and understandably. Any incorrect statement and or understatement, you need to show me the work. If you don't show me the work, you have no reason to get the final answer correct. In fact, you may have different wrong solutions at the end, but if it is just miscomputation, let's say for example, you compute all of this correctly, the procedure is correct, you just happen to miss negative sign here. And then you carry that mistake properly for the rest of the work. Then I may penalize you only 1 point because you make a silly mistake, but everybody makes silly mistake, right? So speaking about partial points, in fact, most of the points coming from your work, okay? I give only 1 point at most. Most of the time I give 0 point if you don't show me any work and suddenly come up with the right answer. Okay? You may show me the work and come up with the right answer, but if your work is not neat, it's not clear, it's not systematic, I still penalize you. Okay? I want you to be mature enough. You're in calculus 2, so you should be mature enough to learn, to know how to show your work properly. Okay? You're in calculus 2, so I expect a lot from calculus 2. Imagine what kind of students I want to get in my calculus 3. That's how I think about it. Okay? You can also see my test 3 here and solution. I just don't post my test 4, huh? Yeah, well, anyway, That's from spring 20. Actually, we can go back further. I taught calculus 2 also in fall 18. In fall 18, I taught calculus 2. Oh, I don't post anything there. Sorry. Did I teach any calculus 2 prior to that? Oh, did I click this one? This is the one I showed you earlier, huh? Oh, no. Yeah, this is from fall 19, test 1. Oh, this is with solution already. Test 1 and solution. This is what it's supposed to be. Okay, so this is the blank test. The one inside the parentheses is the solution. Now, like apparently here, I have the blank test, but I don't have the solution. Test 3, I have the blank test. And I also have the solution. Is it what happened? This is the solution. Now I need to look for the file. This is not posted correctly. Anyway, so you can dig in to my old previous semester and look for my old tests. If I were you, I will download all of them. I will download all of the calculus 2 material from the past. And I taught calculus 2 twice also at East LA College, spring 11. Test 1, solution. No test, no blank test, but I have solution. Test 3 with solution. Let's click test 3. That's the test. And this is the solution. Okay. Now, again, like what I said earlier, I did it twice at East LA College, spring 11 and fall 13. Test 1 solution, test 2 solution, test 3 solution, test 4 no solution. Okay, that's for my website. If you wonder where you can study on the top of this, can you get me more sample problem for test Thomas? Go to here on Playground, test Playground, go to USC Math Department Test Finance. I did my PhD at USC. I did my master's at Castle LA. Then you will see Math 126 there. That's their calculus 2. And they have at least, how many sets here? At least 20 sets of previous department final you can study from. The material for their calculus 2 is slightly different from ours, but you still can study from there. And usually this is what I do though. Usually this is what I do. Let's say 1 week before the test, I will tell you, oh, you know what, you can study for your test 2 already. And if you want to study more, you can go to USC Department Final on fall 2001, question number what, spring 2002, question number what, and so on and so forth. Okay, that's for my website. That's for my website. Oops. Go back to my syllabus. Is there anything else you think I forgot to cover? Any question?
So is the class starting at 7 o'clock or 7:20?
7:20.
Okay.
Yeah, the class start at 7:20. But I may start my Zoom a bit earlier in case you have any question before class. You know,
All right.
my class actually ends at 7:05 for my stats class. But when I set up the Zoom, they make it how to say, the time actually on the quarters. So I cannot start at 7:20. I can start at 7 o'clock or 7:15. You see what I mean? So I just make it 7 o'clock. You know, but my other class ends at 7:05. So after that class, I log off from their Zoom and I log on to your Zoom right away. And once I get in, if I don't see anybody asking me questions, then I go grab a little dinner. Okay. Now, if you have no question, then let's get a break. We come back right now. It's 8:14. We get our break. We come back at 8:25. Okay. See you later. We will start with section 6.1 inverse function. Every time we talk about inverse function, we need to talk first about one-to-one function. What is one-to-one function? Definition. A function is one-to-one if for every element I think we can erase the word for. If every element in the range corresponds to exactly one element in the domain. So if we look at the mapping, suppose this is the set of domain, and this is the set of range. And first it has to be a function. So it has to be that for every element in the domain, every element in the domain corresponds to exactly one element in the range. Now that's a function. That's a function. Now, for that to be a one-to-one function, then every element in the range corresponds to exactly only one element in the domain. So suppose I have the following. Suppose I have the following situation. This is not a function. This is not a function. Why? Because you can find an element in the domain corresponds to two elements in the range. If we look at the corresponding situation in coordinate system, you can say this is like the following. This is the situation where for the same x, you have two different y's. It doesn't satisfy the vertical line test. Therefore, it is not a function. Okay? Now, but what is not one-to-one? A function is not one-to-one. A function is not one-to-one if there's an element in the range corresponds to more than one element in the domain. Something like this. Then this is not one-to-one. It is a function, but it is not one-to-one. This is a function, but not one-to-one. The corresponding situation is like if you have the graph of x squared, y equals to x squared, right? This is a function, but this is not one-to-one. Why? Because there's an element in the range corresponds to two elements in the domain. You see what I mean? Okay, so one-to-one function needs to satisfy to the graph of one-to-one function needs to satisfy two situations. It has to satisfy vertical line test so that it is a function. Second, it has to satisfy horizontal line test for that to be one-to-one. So keep in mind a function and one-to-one. The graph needs to satisfy vertical line test to be a function. And it has to satisfy horizontal line test to be one-to-one. Okay. So mapping wise, then a function is a one-to-one function if you have this kind of pair. Each domain have a unique range. Each element in the range have a unique element in the domain to correspond to. Okay. Now that's for a one-to-one function. Now how do we define inverse function? Let f(x) be a one-to-one function. Then f inverse x is the inverse of fx and is a function in itself. In other words, f compose f inverse of x is equals to x. F inverse compose f of x is also equals to x. Basically, f as a function cancels f inverse. F inverse cancels the function. So you can think of it this way. If the function sends x to y, then the inverse function will send y back to x. Okay, inverse function will send y back to x. Now, for the inverse to be also a function, it has to be one-to-one. Let me say it this way, note. Every function has an inverse. The function doesn't have to be one-to-one to have an inverse. Every function has an inverse. Okay, but only one-to-one function has only a one-to-one function has an inverse that is also a function. Okay, now let me illustrate that using actual example. For example, let fx equal to x squared. Or you can see this as y equals to x squared. The graph is, of course, we know it looks like this. Okay, now the inverse of this function, the inverse is x equals to y squared. Okay, so if you want to do inverse of a function, what you can do is you change the y becomes x, the x becomes y. You will get the inverse right away. Okay, this is y equals to x squared. Okay, y equals to x squared is a function of x. Okay, now notice that the inverse is x equals to y squared. This is the inverse. Okay, so every function you have, you can find the inverse by swapping x and y. Once you swap the x and y, you get the inverse. The problem is this inverse is not a function because it doesn't satisfy a vertical line test. Okay, it doesn't satisfy vertical line test. Okay, now why is the inverse not a function in this case? Well, because the function is not one-to-one. Right? Y equals to x squared is a function, but not one-to-one. Therefore, x equals to y squared. If we simplify that, we will get y equals to plus minus square root of x, right? Okay, now, because it is not a function, we don't have the right to use f inverse notation. We don't have the right to use function notation. Okay? It is a relation. Okay, y is a relation to x, but y is not a function of x. You can find two x's. You can find one x that gives you different y's. Okay, you can find two different y's that give you one x. Now, this is an example that a function can have an inverse, but the inverse is not a function. So coming back to our topic here, so inverse and functions are two different things. Okay, for us to have an inverse function, you first need to have a function, and that function has to be one-to-one. Then we can talk about inverse function. Okay, but every function has an inverse. Keep this in mind. A lot of instructors, some instructors disagree with my statement here, but it is true though. Every function has an inverse. Okay, and if you look back to your pre-calculus, you will see that the inverse of a function, basically the reflection of the graph of an inverse of a function is the reflection of that graph with respect to y equals to x line. Then you will get the inverse. Okay, but the inverse may not be a function. Okay, now y equals to x squared, we know is a function that is not one-to-one. Now, suppose we grab the one-to-one function. How do we find the inverse function? To find inverse function, of one-to-one function, we follow these 4 steps. The first one, so let's say we are given fx, y equals to fx. then the first step, change fx to y. Let's say, for example, you have fx equals to 2x plus 3. You know, this is a line whose slope is non-zero. It has a slope, but the slope is not zero. So it is, the graph looks like this approximately, right? So it is a one-to-one function. Because it is one-to-one function, then it must have inverse function. So the first step is to change fx to y. The second step, we swap x and y. X becomes y, y becomes x. Now, if you think about it, the inversing is actually done in the second step. The inversing is done in the second step. Okay. The third step, we isolate, we solve for, solve for y. So step 3, x minus 3 equals to 2y, so y equals to x minus 3 over 2. We try to isolate the y. Now, if y can be isolated by itself, okay, and there's no ambiguity on the x, then we can replace y by f inverse x. So our step 4 here, f inverse x equals to x minus 3 over 2. Okay, now I did an easy problem though. I did an easy problem, but I would like you to try a problem that is not as easy. Let's say, for example, I pick question from section 6.1, number 24. Number 24, find the inverse function of fx equals to 4x minus 1 over 2x plus 3. Now let me ask you to get the inverse of this function. Now this function is one-to-one. You will see, actually you're supposed to know that this function is one-to-one from pre-calculus. From pre-calculus, you're supposed to know that this function is one-to-one. So we can go ahead, knowing that this function is one-to-one, using these 4 steps, give me the inverse function. Let me give you 3 minutes for this. Okay, let me start. So my step 1, I change the fx becomes y. My step 2, I swap the x and the y. Yeah, this is when the inversing happens. Step 3, I try to solve for y. I'm sorry, it should be y. And isolate the y. Factor the y here to x minus 4 equals to negative 3x minus 1. So y is equal to negative 3x minus 1 over 2x minus 4. Now you know, by the way, we usually do this. We can factor the negative on the top, right? And I can factor the negative at the bottom, basically by reversing the order of subtraction such that the negative cancels. So I'm okay if you stop here for step 3, but there are times in our textbook they actually stop here. So they kind of like absorb the negative on the numerator by reversing the order subtraction on the denominator. So finally, the inverse function of inverse x is now 3x plus 1 over 4 minus 2x. Okay. Now, one big issue that you will see later on, one big question that we see later on, one big question, how to know or to check if a function is one-to-one. There are two well-known methods. The first one is more standard, the algebra method. Let's call that algebra method. Basically, you let y equals to phi 1, and you will come up with x2 equals to x1. In other words, to show that it is one-to-one, the same value of y will lead to same value of x. Okay, but this is actually more useful. The converse is more useful to show if a function is not one-to-one. To show a function is not one-to-one without graphing it, to show a function is not one-to-one, find two different axes, find x1 not equals to x2, but fx1 is equals to fx2. Basically, you try to find the counterexample. Now, another method is show that this is actually what you learned from Calculus 1. Show that fx is continuous on an interval and the derivative is strictly positive or strictly negative, except at some point. Strictly positive or strictly negative in that interval. If so, then the function is one-to-one in that interval. Okay, so let's see. For example, For example, question number 13. For example, question number 13 in our textbook. Show that this function, determine whether this function is one-to-one. Number 13, hx equals to 1 plus cosine x. Is it one-to-one? Not one-to-one. Why? Because h0 is 1 plus cosine 0, there's another 1, which is 2. But h2 pi is 1 plus cosine 2 pi, that's also 1 plus 1, which is 2. So you see, you have two different axes that give you the same y's. So it is not one-to-one. Now, one way to make not a one-to-one function becomes one-to-one is by restricting the domain. So you have the same function, right? But this time you restrict the domain to 0 to pi. Why 0 to pi? Well, because when we do the derivative of hx will be negative sine x, okay, which will be negative in this interval. I think I should say it's negative for x element of 0 to pi, not including the endpoints. So you see this function is strictly decreasing in the interval except at the endpoint. And because it is strictly decreasing, or in other case strictly increasing, then the function is one-to-one in that interval. Okay, let's do more problem. For example, number 18. Number 18, let fx equals to x to the 5th plus x cubed plus x. And the question is part A, find f inverse 3. How do we do that? Find f inverse 3. Let f inverse 3 be equals to x. That implies 3 equals to fx. Right? Which means 3 equals to x to the 5th plus x cubed plus x. Now, can you tell what is x? The x equals to 1. But Thomas, how do you know that x equals to 1? When I plug in 1 to this equation, it gives me 3 on the other side. So it must be 1. But why it cannot be other number than 1? How do we know, Thomas, that 1 is the only answer? How do we know that 1 is the only answer? Well, because the function is one-to-one. Okay. Now, that's the nice thing about inverse one-to-one function. If you find a solution, or in this case, a solution or a root, then that it is the solution. One-to-oneness implies uniqueness. If you can find a solution, that is the solution. Okay? Because of one-to-oneness. Because of one-to-oneness. Now, of course, you may ask, but Thomas, there's no one-to-one statement there. How do we know this function is one-to-one? The question, if you have the textbook, does not say this function is one-to-one. Then let's show that first then. How do we know this function is one-to-one? And I do the arithmetic. I get 5x to the fourth plus 3x squared plus 1. Okay, and this is strictly greater equals to 0 plus 0 plus 1. Right? You see what I mean? This guy is at least 0. This guy is at least 0. Right? Okay, so this is strictly greater than 0. In other words, so fx is an increasing function. Because fx is an increasing function, then fx must be one-to-one. Now, once we know it is one-to-one, then any answer is the answer. Any solution is the solution. Okay? Part B. Part B. Find f of f inverse of -2. Well, we know f cancels f inverse cancel f. So this should be, the answer should be -2. Okay, so the answer should be -2. But more things to say here, though. Some details is required. We need to be careful. We need to make sure that that y equals to -2 is in the range of fx. Yeah, that's a little detail we need to fill in. That's a little detail we need to fill in. How do we show that the range of fx includes -2? In other words, -2 is an element of the range of fx. Okay, how do we do that? Well, we don't need to find the x that gives us -2. No need, no need, no need. We don't need to find x such that fx equals to -2. No need. We just need to make sure that the range of fx includes -2. And how do we do that? How do we do that? We can use intermediate value theorem. Use intermediate value theorem. Use intermediate value theorem. Okay, what is f0? F0 is 0. F -1 is -3. At the same time, fx is polynomial. So it's continuous, right? And therefore, we can use intermediate value theorem. Now, f0 is 0, f negative 1 is negative 3. So by intermediate value theorem, negative 2 is in the range of fx. Can you picture that? Let me try to help. Okay, so here's my, let's say this is my number line here. f0 is 0, f negative 1 is negative 3. Now, because the function is continuous, then in one or another way, the function must look like this, right? Okay. In other words, in other words, there must be an x, such that the y is negative 2. That's all we need. We need to guarantee the existence of negative 2 in the range. That's all we need. We don't need to find what is the x such that fx is negative 2. We don't need to. Okay? Now, once negative 2 in the range, then we can make sure that this f and f inverse cancels. Now, Thomas, why do you want to talk about that? Think about the following question. Consider this a counter example. Let's say let fx equals to what is good? Let's say e to the x. Let's say fx is e to the x. Okay, now, from pre-calculus, we learned that the e to the x is a one-to-one function. So f inverse of x is natural log of x, right? Now, the thing is, so what is f of f inverse of negative 2? Thomas, f and f inverse cancels each other. Be a bit careful. Be a bit careful. It's not always true. Okay, it's not always true. The problem here is negative 2. Negative 2 is not in the domain of the inverse. In other words, f inverse negative 2, which is ln of negative 2, is undefined. You see what I mean? Okay, so the answer for this, should not be negative 2, but undefined. So Thomas, why this guy here is undefined and not the earlier case? What happened earlier is negative 2 is part of the range. Okay? It's the range of fx, such that by one-to-oneness, then as long as it is in one of them, it will be on the other one. Okay, now, it is not the case for this example here. Okay, so in other words, these two guys only cancel each other if some requirement being satisfied. And what requirement is that? It has to be in the domain or the range of one of them. In this case, it has to be in the domain of f inverse. Okay, or negative 2 must be in the range of the function. You see, e to the x will always be a positive number. Okay, so if you think about it, can you find the x such that fx equals to negative 2? There's nothing. There's nothing, right? There's nothing. There's nothing. That's how we see it. So So even though it seems to be an easy problem, it is not that easy. It's actually not that easy. Okay, some details should be paid attention there. Okay, let's do one more little issue problem. Some function seems to be not one-to-one unless we do the restriction. Some function is not one-to-one unless we do restriction. So let's say, for example, I do number, let's do number 28. So fx is equal to 2x squared minus 8x. Now, if you stop here, then this is clearly not a one-to-one function. However, if we restrict the domain, then it has a chance to be one-to-one. But pay attention to details though. You are in Calc 2, so detail is very important. First step, find f inverse x. First step, I change the fx becomes y. Right? The second step, I change the y becomes x. The devil is in the detail. Most of the time, you don't write this down. Now, this time, if you don't write it down, you will lose it. Why? Because when you change the x becomes y and y becomes x, this should change also. Okay, you see that? That's actually the key. That's actually the key. Okay, so when we try to solve for y, I think we'll do completing the square thingy. Okay. So x over 2 equals to y squared minus 4y, where the y is greater or equals to 2. And I complete that by adding 4. I hope you remember how to complete a square. If you don't remember, then study. Oops, I need to add 4 here. So x plus 8 over 2 equals to y minus 2 squared, where the y is greater or equals to 2. And I apply the square root, right? I apply the square root. Now the thing is, when I apply the square root, which one do I use? The plus or the minus? How do I know which one I use? Well, the key is actually here. You see that y minus 2 has to be greater or equals to 0, right? Therefore, I need to cancel the negative part and just take the positive branch. Okay, so in other words, you see the devil is in the detail, right? You have to cancel this one. And then y is equal to 2 plus square root of x plus 8 over 2. Step 4, f inverse, is it f or h? That's f. Okay. So f inverse x is equal to 2 plus, let me rationalize the denominator, 1/2 square root of 2x plus 16. Okay, if I rationalize the denominator. Okay, now without this restriction that you carry through here, you won't realize that you need to use plus minus here and cancel the negative. Okay? Yeah, that's the detail you need to pay attention to. Now, let's get to formulas. Let's get to formulas. One important ingredient for our formula later on is the fact that the graph of f inverse x is the graph of fx reflected with respect to y equals to x line. Okay, so we can see, for example, I have a graph that looks like this. Let's say I have a graph that looks like this. Then, let's say that's y equals to fx. Then the inverse function, that's a one-to-one function, right? Then the inverse function will be the reflection of that function with respect to this line. Still good, solid. Okay, so for example, the y-intercept becomes the x-intercept. Okay, you will see actually this phenomenon, a very nice phenomenon. The domain of fx is equal to, oops, I have a lot of, yeah, the domain of fx is equal to the range of f inverse x. The range of fx will become the domain of f inverse x. Okay, now x-intercept of fx not equal to but related to the y-intercept of f inverse x. And y-intercept of fx is related to the x-intercept of f inverse x. And that's what we see in this graph actually. Yeah, because this y-intercept here of the fx being reflected to become the x-intercept of the inverse function. Then you will see the asymptotes also work the same way. Okay, now let me show you something in my opinion help us to picture that even better. Two well-known functions that are inverse to each other. Y equals to e to the x. Now we know this function from precalculus, right? Okay, and compare that to y equals to a natural log of x. Let me zoom that a bit. I use this only as an example. Okay, I use this only as an example. So this is fx equals to e to the x, and this guy is f inverse x equals to natural log of x. We know they are inverse to each other. Okay. Now the challenge of our calculus 2 is the following. The challenge of our calculus 2 is the following. Can I find the slope of the line tangent to a point on the graph of the inverse function? Can you find the slope here without actually finding the inverse function? Let fx be given. Let fx be given. Find the derivative of the inverse function at a without finding the inverse function first. That's the challenge. Okay, that's the big question. Now, how do we do that? How do we do that? This is where we will do some deeper analysis on the graph. Now, the slope here, oops, the slope here, notice that this curve, the red curve, the inverse function, is the reflection with respect to y equals to x line. Right? It's that reflection here, such that the slope here must be the reciprocal of the slope here. Must be the reciprocal. So there is, let's say the slope here is m star, then the slope here is 1 over m star. Okay, so that's what we observe. Let me write it down first. Observation. Suppose this is my A. Let's say this is point A here. Therefore, the coordinate here is A, comma, F inverse A. Is it right? Then this coordinate here must be F inverse of A, comma, A. Is it right? Okay, so suppose, the first one, let A, comma, F inverse A is on the graph of F inverse X. Then F inverse A, comma A, when we swap the X and the Y, must be on the graph of Fx. You see that? That's the first observation. The second observation, the slope of the line tangent to f inverse x at x equals to a. This line, while the one I'm talking about is this line here. Let me mark it as yellow. Is equal to 1 over the slope, let me use parentheses, the slope of the line tangent to fx at x equals to f inverse a. Okay, if I mark this using the blue shadow, refers to the slope of this line here. Okay, in other words, if I can find the slope of the line tangent to the original function at f inverse a, doing the reciprocal will give me the slope of the line tangent to the inverse function at a. Okay, now let's call this m the way I denoted that earlier. And this is my m star. Okay, now what is m star? M star is the slope, that is the derivative of the function, right, at f inverse a, right? That's the slope, that's the first derivative, okay, of fx, where the x is f inverse a. So let me use this color here. Now, if that's m star, then m will be 1 over f inverse, f prime of f inverse of a. Furthermore, for the first, the derivative of f inverse at a, right? The slope of the inverse function at a, okay, is equal to 1 over the derivative of the function at f inverse a. Now, you need to memorize this formula very, very well. Example. How do we use this? Let's say I pick question number 40. 40, let fx equals to x cubed plus 3 sine x plus 2 cosine x. and a equals to 2. Find the derivative of f inverse at 2. Now, what you don't want to do is to try to find inverse of the function fx. I don't think it's doable. I don't think it's doable. Okay, our solution. We will use that formula, right? We'll use this formula. We'll use this formula here. So the derivative of inverse function at 2 is equal to 1 over the derivative of the original function at inverse function of 2. But what is f inverse 2? F inverse 2 equals to what? In other words, suppose I call f inverse of 2 equals to x, then 2 equals to fx, right? So 2 equals to x cubed plus 3 sine x plus 2 cosine x. What will x be? X equals to what? Do it by guessing. X equals to, I need this to be 2, 0, 0. Make it 0, make it 0, but this one will be 2. That's when x equals to 0. Okay, so that's our first part. So basically later on, this is equals to 1 over f prime 0, right? But the way we'll do the work, basically we set it up this way. I find the inverse first. I don't need to find the inverse function. I just need to find the inverse function of 2. I don't need to find the inverse as a function. Okay, and then second part I do is to find the derivative of fx, which is 3x squared plus 3 cosine x minus 2 sine x. So f prime 0 will be 0 plus 3 minus 0, that's 3. Okay, then part C. The derivative of inverse function at 2 will be 1 over the derivative of the function at inverse of 2. We know from part A this is f prime of 0. We know from part B this is 1 over 2. Okay. Now, if you use the formula right away, you kind of like lose it, like, because you don't even know what is this, right? But at least I write it down here so that you know, oh, this is what I need to do first. That's what I do there. And then after that, I need to find this. That's what I do here. Okay? That's how we show the work. Now, sometimes if you are lucky, the function is simple enough that you can find the inverse function, and from there you do the derivative. But if the question is find the derivative of inverse function, just do it that way. You know, just do it that way. Okay. Now let me do, I think I want to do one more problem from here. Number 42 maybe. Number 42, let fx equals to the square root of x cubed plus x squared plus x plus 1, where the a is 2. The question is find the derivative of inverse function at 2. Solution. First, I want to find what is f inverse 2 first. Let's say let f inverse 2 is x, so 2 is equals to fx, which is equal to the square root of x cubed plus x squared plus x plus 1. I square both sides, I get 4 equals to x cubed plus x squared plus x plus 1. Now this function is not one-to-one. I don't think this function is one-to-one. Maybe, maybe not. Maybe, maybe not. Oh, by the way, I'm sorry. This function is one-to-one. This function is one-to-one because of the square root. Well, anyway, I assume one-to-oneness because they use this notation, f inverse, right? Okay, because they use the notation f inverse, then it has to be one-to-one. Otherwise, they are lying. But then, what is x such that x cubed plus x squared plus x plus 1 equals to 4? Do the guessing. What will x be?
One.
1, okay. Then the second step we do is to find the derivative of fx. The derivative of fx will be 1/2 times x cubed plus x squared plus x plus 1 to the power of negative 1/2. See, basically I do it this way. This is x cubed plus x squared plus x plus 1 to the power of 1/2, right? So I use power rule and chain rule to get the derivative. 3x squared plus 2x plus 1. Okay, and then plug in 1 in x. Right? So this is 1/2 times 1 over square root of 4 times 6. That will give me 3 over 2. Okay, so the final step, the derivative of f inverse at 2 is equal to the reciprocal of that number, equals to 2/3. Let me go slow a bit. This is f prime of f inverse at 2, which is 1 over f prime at 1, which is 1 over 3/2, which is 2/3. Okay? Your suggested homework from here, suggested homework means you don't need to turn it in. Suggested homework means you don't need to turn it in. Suggested homework will be from section 6.1. I would like you to think about number 3 to number 27. And then number 23, 25, 27, number 35 to number 45. Just do the odd numbers. Now you don't need to turn this in, but I would like you to do it so that in case to actually just do it and then get good foundation in your calc too. Okay, that's for 6.1. Now 6.2 exponential function. I still have around 20 minutes, so let me just use it. I cannot finish it though. Let me call that 6.2a. Exponential functions. Exponential functions. Now, a function is an exponential function if let a be positive and a is not equals to 1. Then an exponential function is given by fx equals to a to the x. One classic example is fx equals to 2 to the x, or fx equals to e to the x. As long as the base is not zero, is positive and not 1. Okay, as long as the base is positive and not 1. Now we learned from pre-calculus, actually we learned this from algebra 2 and pre-calculus, the following important characteristic. Okay, first one, the domain is all real numbers. Okay, whatever x you plug in here, you will get a real number. Second, the range is the range is positive. It's from 0 to infinity. Or in calculus, sometimes we use this notation. Positive real number. Third, no x-intercept. Actually, you can see directly from the range that y equals 0 is not part of the range. Right? Y equals 0 is not part of the range. Therefore, there's no x-intercept. 4, the y-intercept is 0, 1. In fact, it has asymptote. Horizontal asymptote, y equals to 0. To be more precise, instead of just saying horizontal asymptote, you see that the limit when x goes to infinity, x goes to negative infinity of a to the x is 0 if a is greater than 1. The limit when x goes to positive infinity for a to the x is 0 if a is between 0 to 1, if the base is between 0 to 1. Maybe I say it this way. If the base is is greater than 1, the function is increasing. If the base is greater than 1, the function is increasing. And you know, increasing function is 1 to 1, right? Okay. While if the base is positive but less than 1, the function will be decreasing. Okay. Now, those are important characteristics of our exponential functions. Very, very important. Okay. Some properties, important properties. You can see this on the bottom of page 393. The first one, the product of two same bases equals to the base to the power of the sum of the exponent. And of course, if you divide the same base, then that's the same base to the power of the difference of the exponents. The power rule, a to the x to the y equals to a to the xy. And finally, ab to the x, the product to some power equals to a to the x times b to the x. So I go over the material that we have seen before in pre-calculus, and just to review a little bit. Now, let's see what we can do here. Oh, hold on, I have only 5 minutes left. Let me just end it here. Let me ask you to read 6.2. And on Wednesday, we'll continue on this. Okay, we'll continue on this. If you don't have the textbook, then look at our file folder. That will be section 7.2 in the 5th edition. Any question? Nobody have any question? Okay, fine. And I will just end it here. I meet you on Wednesday. On Wednesday, I will go continue from this 6.2. Okay, but I will do some problems from pre-calculus level, and then finishing up this 6.2 with the derivative and integral of exponential function. Okay, see you then on Wednesday.
Thank you.
You're welcome.